Great. Well, I think we have most people joining here. Thanks everybody again for joining. Right here is going to be the second workshop of our series with the DAO Hack with BitDAO. This is going to be the performance bonds workshop. Today with me, I have Aodhgan. He's a smart contract engineer for Windranger Labs. They currently work creating products in the BitDAO ecosystem. So they're heavily tied with BitDAO. And he kind of has some products in code base he wants to show you today here for this performance bonds workshop. So I'm going to actually turn it over to him. He's a very bright guy, and I hope to learn a lot here today, even myself. So I'll turn it over to him. Here's Aodhgan.
Yeah, thank you, Steve. So my name is Aodhgan. I've been doing smart contracts for a few years. Recently joined Windranger, which is kind of associated with BitDAO, which is one of the largest DAOs out there, and focused on building like tools and infrastructure for DAOs, as well as nurturing autonomous entities, which are kind of like sub-DAOs. So one of the products that we've been working on is performance bonds, and that's what this workshop is going to be focused on. So yeah, just today I'm going to give a run through like why we're building performance bonds, like how they're used and what problem they solve. We're going to have a little look at the specification. So this is the initial version of the bronze product. It's a pretty minimal specification. So we can step through that. We're going to have a look at the smart contract architecture, how we have implemented it, and that might give you some insight as to like how you can use this product creatively or in a workshop setting. We're going to do a walkthrough of the code base, and then we can have a example integration if we have time at the end. So why do we want to build performance bonds? Well, if you have a treasury that wants to fund autonomous entities, you have a lot of counterparty risk in terms of if you start giving away tokens, say in the case of BitDAO, bit tokens, as you invest more and more of your treasury, it becomes more and more like risky, essentially. So performance bonds are a way to reduce that risk, reduce that economic risk. So how it basically works is an autonomous entity will come along and propose a project. So if we have like a scenario here where a made-up DAO called Blimp DAO wants to buy a blimp, and they approach BitDAO and they say, hey, we'll give you some collateral. So the bond can be over or under collateralized. So we'll give you some collateral or something in exchange for a load of these bit tokens. And then because we're going to buy a blimp. And then if they don't buy the blimp after a particular time period, the collateral that the Blimp DAO supporters provided is returned to the BitDAO treasury. So not as much a loss would be realized by BitDAO is essentially the idea. So that reduces the risk to everybody involved. So that's the sad case where they fail to buy the blimp. But if they bought the blimp, the people who provided the underlying collateral ETH in this case is like returned to them. So everybody is happy. So how else would these performance bonds? So that's kind of like case 2 here, like reducing the ability for a new autonomous entity to kind of rug pull It also increases community engagement. So this is like a product, okay, so it's mostly built for BitDAO, but other DAOs can use it too. So it like gives them a way to incentivize community engagement. So if you have a DAO and it has a token and it's just kind of sitting there and you maybe using it for on-chain governance, maybe you've delegated it or whatever. So it's something, it gives you some sort of use case or utility for your token as well. As well as kind of like aligning like long-term incentives. So if you want people to hold your token for like a longer period of time, why not lock it into one of these performance bonds? And it just increases long-term alignment. And then for use case number 3 here, DAO co-investments. So like, it's kind of like, oh, there's a lot of ideas floating around and a lot of autonomous entities that could be formed. But this is one of the ways that an autonomous entity could start, just like BlimpDAO. Otherwise, it's a good starting or entry point to becoming an autonomous entity. So just going to skip ahead from this slide and maybe come back to it. So this is a screenshot of like what the product might look like from actual users perspective. So just looking at the user types, right? There's 3 main types. There's like a proposer. So that's an outside party or an autonomous entity that is like looking for funding, basically. So they're proposing, they're going to create a bond and then try and get people to purchase it. There's a bond admin who kind of, and these 2 parties can be the same, where it's like they've created a bond and then they have all of the kind of admin functionality involved around it, which we'll look at in more detail later. And then there's a guarantor, which is like an end user, so a holder of whatever token, an investor basically. So this is like a screenshot of what it might look like, a mocked up screenshot of like what the actual end user might see. So you can see here that it's like, this is the name of the autonomous entity. This is like the date that the performance bond will expire by. So in the case of BlimpDAO, it would be like the 1st of June. They must have had purchased the Blimp by the 1st of June. This is how much room there is in the bond. So as we'll look at in the specification, there's like a maximum amount. There's like a minimum amount for the performance bond to exist. And then you can see there'd be like an input. You want to contribute like 100 tokens, 1,000 tokens. And you can see here in the background that there's like, these are all of the different bonds available to the user at that moment in time. So you can see here, this is like a hat tip to the car or Lambo project that recently happened with BitDAO as well, the NFT project. So yeah. So as we can see here, like, so the performance bond is dependent upon certain off-chain criteria, or it can be off-chain or on-chain criteria being met. So these performance factors. So in the case that this is like a new autonomous entity and they're looking for funding, they have like these are their targets that they have to hit, right? So they have to have a multi-sig set up by the 1st of June. They have to have a landing page set up by the 1st of June, and any other kind of factors, right? So as we'll see in the specification, if they don't reach these factors, then some of the bond underlying collateral that the users have provided will be reduced over time. So the kind of life cycle of the bond is that the bond is created first, or is proposed. So an autonomous entity comes along and says, we want funding for this project, like BlimpDAO. So this kind of mostly would happen offline, you know, and offline meaning like Discord or in some sort of forum or some sort of maybe even snapshot. So then the bond is like actually created on chain. And after that point, users or guarantors can start purchasing the bond, any amount of bond that they want. So the bond in this case is like, as we'll see, is represented by an ERC20. The bond is filled, so this means that the maximum cap, the amount of collateral provided has reached a minimum and is under the maximum. So it's kind of it's available to be kind of closed over time. So no more people can kind of come in and out, and everything is set in stone until the bond is assessed. So then again, a little bit blimped out, go and buy the blimp. And then on chain, like it's assessed whether or not all of the performance criteria has been met. And then when it's available, people can come and start redeeming the bond. So in the happy case, the blimp has been bought. The collateral, people can come and pull their collateral back from the performance bond contract. So yeah, I think we've mostly mentioned these, and these next couple of slides are mostly here for reference after the workshop. So I won't go into too much detail, but I think maybe as this is like a technical workshop, we should step right into the code, and then maybe we can come back to the specification as we move along. So just the contract architecture, right? So it's a I would say a medium-sized complexity system in terms of smart contracts. But the two important smart contracts are the bond factory, which has the create bond method on it. So this will actually create a bond, and a bond is each performance bond is its own smart contract. So within create bond, we have created this new ERC20 single collateral bond. So for the first version of performance bonds, there is only the ability to provide one underlying ERC20 as collateral. And we have not yet built the functionality to accept like a ERC721. So it's just a simple, it takes one ERC20 compatible token. So that as the bond itself is an ERC20 token, there's like two methods that users mostly would care about, and it's deposit. So that's when you are purchasing a bond as a user, and then redeem. So that's at the end of the life cycle, like we just talked about, when you want to get your funding back or your collateral back from the performance bond. So I'm gonna start sharing a different screen now, I think. So this, you can see my Visual Studio.
Yes, we can see your VS.
So this repo is available. There'll be a link in the slides, but it's available in here, and this is Windranger IO. And then, so this sort of project is related to the treasury. So this is a public repo, and we're just going to be looking. I've obviously cloned this on my machine or whatever. And this in turn actually is, I should point out at this stage, is like a fork of the template repo. So we have if you want to get started on a smart contract project, we have a template, a public template that you can fork, and it's set up with all of it's opinionated, so it's set up with all of the kind of stuff we use to develop smart contracts. Some of the best practices here at Windranger. So just like a high level, we use Solidity for most of our contracts. We also use TypeScript and Hardhat like extensively. And I think you'll find that there's like a huge focus on quality assurance or testing within all of our smart contracts at Windranger. As I'm sure everybody is aware of the risks involved with writing immutable code. So our treasury repo is a fork of this in turn. So we'll be having a look at this. This is where the performance bonds, so the performance bond contracts live within here. So we have the bond contracts here. And this is like the treasury repo is because we are planning more than one set of contracts. So there'll be performance bonds, and then it'll also be like a staking product that we're also currently working towards. But we'll just focus on the performance bonds today. So this is, as you can see, so I mentioned earlier that the main entry point into the system is the bond factory. So here we were out here, we've stepped into bond, and then we've gone into bond factory. So we're using Solidity 8 and above, so 0.8 and above. So we have all of the nice new safe mat stuff and everything. We use extensively Open Zeppelin contracts. All of our contracts are actually upgradable, which kind of will facilitate us to move from this MVP that's currently specified out to like a more advanced version. So as I mentioned, this is only accepting one ERC20 as our collateral, and then in future other versions are planned where this accepts more than one token as collateral. So we're using the Open Zeppelin UUPS upgradable style proxy contracts. So that's just to note that. Most of the bonds contracts are also pausable. This is like to mitigate risk or whatever. We envisage like the first users of the performance bond system to be autonomous entities kind of within the greater BitDAO ecosystem. So we already have a few autonomous entities that are like waiting for this product suite to launch. So this is the main entry point into the system. It's actually not like, doesn't have any sort of permissioning on it, so anybody can call it. And then the restriction is actually on the bond, the DAO must all have already like whitelisted both its treasury address and its the acceptable forms of collateral that the DAO is willing to use. But anyone can call this, as we can see, and we will be creating a new ERC single collateral bond contract, which is where the actual meat of the system lies. So we'll step in and have a look at that. It's down here. I don't know why my thing isn't working. So we can see it is like a large contract that is also an ERC20. So this is how the accounting system for the bond works, that when you deposit into this contract, you will tokens will be minted to you. And then when you redeem at the end of the life cycle, tokens will be burned. So that's kind of how the accounting system works. And in the meantime, you can do, as we'll see, we can do all sorts of other things. Then now that we have this bond ERC20 representation in our wallet, you can also then kind of send that around the place and show people your balance or whatever of this particular bond. So we have like, the bond has an associated like time-based life cycle. So we have a few methods in here that shows you when the bond is going to expire, like in Unix based time. This is the interface that it's associated with. It's got like a place to put some metadata about the bond. It's also an ownable contract, so that whoever creates the contract has a load of admin powers. So that relates back to the user type slide I showed at the start, where the bond admin has some particular privileges, such as slashing the bond. So slashing is a concept where if the performance criteria is not met, then the bond admin basically reduces the amount or slashes the amount of collateral within the bond. So if the targets aren't being met, that's the outcome. So yeah, all of there's some of the functionality is possible for safety related reasons. Redeemable is another interface, essentially your abstract contract that shows you that manages when the bond is redeemable or not. And then we've versioned all of our smart contracts, which is literally just like a hard-coded string that shows you what exact version of the contract you're looking at, which can help you out of some complicated scenarios when you're looking at immutable code. So let's just move along and have a look at the deposit function. So how you actually get in and out of the bond. So this is the main function that users are expected to call in order to purchase or support a project such as BlimpDAO. So as we can see, there's like obviously some sanity checks. There's the concept of minimum deposit size, which I've alluded to previously. So when the bond is created, there'll be, say, like a minimum amount that you can contribute. And once you have met this minimum amount, you can continuously buy as many bonds as you want, up to the maximum amount of bonds available for that bond. So yeah, and here is where you transfer in your collateral token. And then down here, we can see that we are internally transferring this ERC20 token to whoever has called this function. And we're emitting events and we're doing some checks. So this is the main entry point. And you can obviously see that it wouldn't make sense to be able to call this when the contract is paused, and also when it's redeemable. So when it moves into the redeemable state, this means that the kind of bond it's over, everything is finished. So you wouldn't be able to deposit in at that stage. So let's look at the completely end of the life cycle function. Oops. So this is the redeem function. Again, you specify the amount that you want to redeem, which is probably just your full balance of. Some more sanity checks. And then this is actually where things get a little bit interesting, because in the meantime, over the life cycle of the bond, some slashing may have occurred if the performance criteria was not met. So we calculate how much slashing occurred if it did. And so say if there was 100 ETH worth of collateral, and there was a slashing event that slashed 10% of all of the collateral. So now there's only 90 ETH worth of collateral back in the performance bond. And that could be because BlimpDAO failed to launch their landing page for their website in time, or something like that. So proportionally, everybody will get back less. So there's a reduction of 10 ETH, so only 90 ETH will get paid back to everyone. So this is where the kind of proportional calculation is happening. And then we are burning this bond ERC20 proportionally for the user for their full amount. because they can't redeem again, but they will only get the amount, the proportional amount that they are entitled to. So yeah, that's kind of the performance bonds contract in a nutshell. How to get in and out. We'll look at a little integration example shortly. But I think it might be worth having a look at the other functions involved here. So this is the slash function that I've been talking about. So slashing is only the owner can do it. So in version 1 of this product, a lot of trust is based on the owner or the admin of the DAO admin that has created this bond. So if it's kind of like a self-policing in a way that the performance criteria is not being reached, and they'll slash for a particular amount and reduce the amount of collateral in the system transferring out to the pre-specified treasury for that particular DAO. So as we can see here, when you're setting up a DAO, each DAO has like, we're keeping a mapping here of like a DAO has an ID, a unique ID of a UN256 across the entire system. And then they have a treasury, they're identified by a treasury and a whitelist of collateral. So if we look at the whitelist, it is like a set, so an open Zeppelin enumerable set of tokens available. And we're also storing the symbols for convenience. So when you create a DAO, you have to specify this stuff like treasury, so that when slashing occurs, the tokens will flow back to this treasury, and the treasury can't be changed. So there's like no rug pulling vector. And the bond, the performance bond, can only be created against collateral that the DAO has specified at the start as well. So yeah, we can see here that it's the collateral, when it's slashing, has been returned to the treasury. Okay. And then there's various, the kind of periphery stuff in here is we're using Open Zeppelin access control, which is pretty cool. Permissioning library, like a hierarchical style role-based access control. So we can see that we have like a kind of top level DAO admin, we have a system admin, and we have a bond admin. So there's like various levels of permissioning of what each of these actors can do based on the spec and like the product requirements. So say, for example, that the system admin is the only role that can perform smart contract upgrades. Whereas the bond admin can do things like slashing and changing particular parameters. What other contracts are interesting? So some of these are, so yeah, we have a concept of a bond curator, which just kind of is like a layer above. If you have a DAO that has several performance bonds at the same time, it kind of groups them together. And we have a bond mediator, which is a kind of another level above again that creates bonds for particular DAOs and manages them in a group together. Do we have any questions before I move forwards to the like integration demo? Maybe if I talk a little bit more about like just the setup in general here, in terms of, so this is our bonds product. Most of the stuff lives inside the this directory here. We also have some stub DAO functionality for what these various treasuries that they just need to be basically compatible for ERC20 tokens to come in and out of. We have some contracts that are used for testing. They're not very interesting. The sweep contracts are if you send a token accidentally to one of these performance bonds, you haven't called deposit or redeem, you've just tried to transfer in and out. It's kind of like prevents and helps with this functionality. And then we have interfaces for planning on how to interface with different strategies that live in different repos and places. So that's pretty much the layout. And in terms of just like the whole repo, so as I mentioned, we use Hardhat, we use a lot of TypeScript. In here, we also use Husky, which is like a pre-commit hook thing that like will run all of the linting. Basically, download the template and play around with it because it's a very detailed and strict environment that helps you produce super clean and mitigates like the risk in terms of code. We're also using type chain. So with TypeScript, I don't know if you guys are familiar with type chain, but it generates TypeScript types for use with testing and even helps you out with deployment. So yeah, I think that's pretty much everything you need to know. So yeah, maybe our testing, we have like unit tests. We also use Slither, which is like a static analysis of the smart contracts. Can help you use Solhint for linting, but Slither can also help you find, it's like you define like a set of rules and it can help you figure out if your contracts are adhering to those rules that are, some of them could be possible like security vulnerabilities. So I recommend checking out that tool as well. So that was the code walkthrough. And then the links are here. So there's probably a better definition of what performance bonds are. This is the treasury that I've just walked through. This is the template that I've been mentioning. We looked at the start. It's also a link. So Windranger are hiring or whatever. So if you're a Solidity developer, product or whatever, even if you're really into testing, you just saw how tight our environment is in terms of testing. So there's that there too. So I think we've got a few minutes. So I'm going to show a demonstration of how we can actually use a performance bond. So the concept here is we're going to show how you can write a contract that deposits into a performance bond. So we're going to create a contract and we're going to call it like wrapped bond. We're going to create a wrapper around our bond. And within our wrapper, so if we were an autonomous entity that wanted to create one of these performance bonds, for some reason, they might also want to mint an NFT. So for each person, like kind of like a POAP style thing. If you guys know that protocol where it's like you get minted an NFT for doing a particular action. So in our case, we want to mint an NFT every time a performance bond, every time you have deposited it into, or yeah, every time you have purchased a performance bond. So you could then add some utility to that NFT, like access into a special channel in Discord or whatever sort of utility, or just use it to display hey, I supported this, the birth of this autonomous entity by purchasing a performance bond. So that's just a quick demonstration that we'll use. And I'll step you guys through how you can interact with these set of performance bond contracts. So I'm gonna like just copy and paste in something. So we obviously have our kind of standard header there for Solidity contracts. And I mentioned we're going to be creating NFTs. So OpenZeppelin have this nice contract where it's like an ERC 721 out of the box with like with the nice ability to mint and burn from whoever sets it up, and just everything is generally set up correctly for this sort of applications. Call it wrapped bond. So we're going to inherit the 721 contract because we want to be able to mint NFTs. So it's saying my editor is complaining, saying that I haven't, that it should be abstract because I haven't implemented whatever this constructor needs. So again, in the interest of time, I know what that constructor wants. It wants if we look down here, it wants all of this stuff, right? So a name, the name of the NFT, the symbol, and the base token URI. So I'm giving it all of that stuff. And also, in this case, we're going to want, so as each bond exists as its own smart contract, we're going to want to tell it where the bond contract actually is. So this is the address of the bond contract. So we're going to set it up in the constructor as well. So right. In the Windranger repos, like we're using yarn or npm. So if you type yarn build, it should compile all of the files, including this new one that we've written called wrapped bond, although it doesn't seem to be having here. So you can see it compiling. It will create, that's the type chain notification saying that it's creating types for this. So, okay, great. It seems to work. So we have our, now we want to interface with the ERC set, ERC 20 single collateral bond that we spent a lot of time looking at earlier. And as we mentioned, like the main way to get in and out is like the deposit and redeem functions. So we're going to want to call this deposit function on the contract. So we're going to write something like function deposit, which will say deposit and get NFT or something like that. And then we're going to want to specify the amount. It's going to be an external function that modifies state that people can see. So, and then we're going to want to call, we want to do some like sanity checks, which we won't do. And then we're going to want to do bond.deposit. So we want to call the deposit function on the bond to get in, right? And then if we look at the function, if this stuff, if it's paused and not redeemable, it will like revert. So we don't really have to worry about that behavior. And it doesn't return anything. So we can just call it like that. And then, so it will successfully step down here. And then we want to mint the NFT. So in our case, it will be, we can just call the mint function that we've inherited by that, including this ERC contract up here. So we're going to want to mint it to the person that called this function, right? So yeah, so now we have successfully implemented like a wrapper contract that has, each time you've created or you've purchased some of the performance bond that you've specified up here, you're now going to also get an NFT. And then we can do the opposite, which is where when the user wants to redeem, so go the other way, when everything is, when the performance bond is finished, maybe you want to keep your NFT forever, or maybe you don't want to burn it, but we can still explore that functionality here. So we're just going to call bond redeem, and then maybe you would want to burn NFT. So you no longer have the NFT, you no longer have this. And let me see what this says. Not sure what argument it takes, but we'll build and see if it complains or not. So yeah, that's just one very basic example of how you could integrate like a performance bond into your bond product, or your DAO product. So yeah, I think that kind of like concludes my walkthrough and my little demo. So if there's any questions, I'd be happy to take them.
Awesome. Thanks, Aodhgan. That was great. Yes, do we have any questions for our speaker while he is still here? Doesn't look like it. Well, thanks again, Aodhgan and Windranger here for speaking at this workshop. It was very great insight into performance bonds, understanding kind of the community engagement within creating these, and awesome demo at the end showcasing how to kind of create this wrapped bond here with some minted NFTs. Very insightful. Thanks to everyone who joined here for this workshop. We will be having a second workshop for the DAO Hackathon next Monday. It is going to be posted on our mediums in our articles. Please look out for that. I'll actually post the link here if I can get to it. One moment. And please, ping me any questions if you are in the DAO Hackathon. I'm happy to schedule a call with you anytime, understand kind of any questions you have and give some feedback. We're here for you. These slides that Aodhgan has shown us will be posted online tomorrow, along with the recording of this event. And awesome. Thanks everybody for coming, and thanks again to Aodhgan Gleeson here for showcasing his talents. It was a great workshop, and we appreciate you taking the time out of your day to come speak with us and kind of show us what you've been doing here at Windranger and BitDAO. So thanks again, and everybody have a great day.